So sometimes I want to represent something in a program that's a grid. So what do I mean by that? I mean literally that I want to have something that has rows and columns. So if I have a little grid here, I could represent something like a tic-tac-toe board. And I would have rows, which is what you're seeing now, and then I could actually subdivide those into columns also, and those would be the vertical separation. So this way would be rows, and this way would be columns, and so that's kind of like a vector that have expanded into 2 dimensions. Okay, so to do that, the first thing you need to know is what we're going to use is not a standard library. It's a little library that sort of came with a textbook and then got modified. But what that means is it's not included in the list of things that comes with a Visual Studio install. We have to get the files and bring them in ourselves to make this library. So I have here on my flash drive a folder called M. I will put that in the handout folder for you. And I'm going to find my project. So here I am in Visual Studio Projects, and here's the project I made already for it. And I need to get that folder so it's pasted next to my CPP file. So I'm going to look for that. Here it is right here. So I'm going to paste this here, and now I've got access to this matrix library. You'll see it has 4 files in it that it's being using. Okay. So when I'm back in my project, when I want to include a library that I'm including locally, I start with include the usual way, and then instead of these brackets, I put quotes, and that shows it that it's a local folder. So I'm going to find this folder M, and I need matrix.h. Okay, and once I do that, now I have the ability to make one of these 2-dimensional structures. So when I'm in main and I want to declare one of these guys, it looks very much like a vector. I write matrix, and then in these kind of brackets I can put the type I want. So this is again a class template, meaning I get to choose what type it is. So let's just say I want to put some numbers in a 2D grid. So I'm going to say this is going to hold ints, and then I can have its name. Just like with vector, there's 3 variations of the constructor. So if I just write this, then it doesn't have any rows or any columns. Its size is 0 in both dimensions. If I know how many rows and columns I want, then I can specify those. So let's make it 3 rows and 4 columns. So rows comes first, columns comes second. Okay, and now that makes a 3x4 grid. And then there's a third variation of the constructor where I give the rows, columns, and what number to fill it with. So let's just fill it with zeros. Okay. Now maybe one of the first things I want to do is I want to print this out so I can see what the heck is inside that grid. Okay. Because we're talking about 2 dimensions, I need 2 for loops, one nested in the other, one that traverses the rows and one that traverses the columns. So let me write one to go across the rows. This guy has a function called numRows that'll calculate for you its number of rows. That's kind of equivalent to .size for a vector or .length for a string. Okay, so I'm going to go across the rows first, and then I'm going to go across the columns. And again, there's a function called numCols that'll grab that for you. Okay, and now if I want to print, I'm going to print to the right first. So I'm going to print what's in the row, column. Note there's 2 sets of square brackets because I have 2 dimensions here. I've always specified rows first and then columns, and probably I want to stick a space between them so they're not smushed together. So that'll go to the right, and then when I get to the end of my columns and I'm ready to go to my next row, I would like to drop down a line. So I'm going to end L right there. Okay, let's print this out and see what we get on the screen. Okay, so I got my rows of 4 zeros going across, and I'm sorry, my columns of 4 zeros going across, and then 3 rows going down. Okay. If I want to get to one of these individual locations, my numbering starts at 0 in both directions. It's starting from the upper left-hand corner, if you imagine that as 0, 0, and then the columns increase to the right, and the rows increase down. So let's say I want to go to row 2 and column 1, and let's put a number in there so you can see it. So there's 99. Let's run this again. So here is row 0, 1, 2 and column 0, 1. So this is 2, 1, and I've set that to a 99. Okay, so I can get to individual locations and set them or retrieve them and print them using its specific row and column numbers. Okay. There's one more function that you might be interested in, and that is if you don't give it a size up front and you want to change the size later, then you can use resize. But this resize needs two numbers. It needs the rows and the columns because there's two dimensions. So let's make it a 3x3 grid. Let's see what comes out on screen. If it's 3x3, and you'll see now they're junk values because I didn't initialize them to anything. So that'll make me a 3x3 grid. Anytime I want to, I can resize it again later. Let's say I want that same number of rows, but a different number of columns. Let's go 10. And so I can ask it to grab its current number of rows, and now it has 10 columns and 3 rows, and I can manipulate data and keep it in a grid in this way.